Hello guys, how are you? So I am streaming some of my videos and I hope now streaming is working here very well because before that I have created one or video related to BERT model architectures but totally it get failed. So I have to check that. I think now it's working properly. So I'm here in this video I'm just going to explain you BERT model architecture, transformer model architecture, encoder, decoder and how you will do the fine-tuning of BERT model end to end and with the deployment of those BERT model. So I am not going to waste your so much time. So before BERT model, I'm just going to tell you sequentially. So BERT model is nothing but bidirectional encoder representation from transformer. So you are going to see this is the whole middle figure. So this is the transformer block, and on the left side you are going to see the one square block. So it's the only encoder part, and right one is the decoder part. So transformer consists of the encoder and decoder part. And when those two parts are connected, it's become the whole transformer architectures. So there are so many transformer models like just which are just utilizing the encoder part. So BERT is the one of this part. And there are some models just which are utilizing decoder part. So GPT models are those decoder type part. And there are some models like BARD or T5 model which are utilizing the encoder and decoder part. So I'm going to tell you some basic differences between the encoder and decoder. They have so many similarities, but you may be going to see the differences. You should know the exact differences. So in the encoder, what happens? Encoder is nothing but uh, the part where it will going to see the we are going to pass the all sentences or sequence lengths at a time parallelly. And in the encoder, it will going to see the context from left and right side. So in the both direction, it will going to see the context. But in the GPT model, it will not going to see the context. Please remember that point very importantly, very carefully. So in the GPT, it will going to see the context from the left to the right, means left to the right until that positions where it has need to predict the next word. So suppose there is a sentence that India is my dash dash, and if the country is the word, then GPT will going to see the only context related to India is my, and it will going to predict the next word. Is it a country or is it any other thing like this only? And based upon those probability, highest probabilities words will be given in the decoder part. So decoder will not going to see the context from both right and left directions. So BERT model will going to see encoder model will going to see the context from left and right side. Then how it will going to learn means if you know already all those contexts. So that's why those encoder or BERT models came with the two basic architectures. Means BERT model have the two parts for its basic architectures, and I will show you. So first one is the mask language models, and another one is the next sentence prediction. So what is mask language model? So mask language model is nothing but where some words in the sentences are given the mask. So there will be some static masking and dynamic masking. So because of that mask positions, BERT model will not going to see all those words as it is. So it will going to try to predict some mask or hidden words. And if model is predicting the right hidden word, then it is considered as a right one. Then it has given the highest score. And if it's predicting negative words, then it has given the penalty and model will try to predict those next word in the next iteration. So this is the mask language model, and how much you should do the mask of those words from given all your text data. So only 20% of all those text data will be done. Means you should do the 20% of the data as a mask, and in that 20% data, only 50% words should be a randomly masked. Means alternative positions. Those 15% words should not be at the exact positions. Remaining 85% should be at the proper positions. Then those model will going to learn very well. And what is next sentence predictions? Means in the BERT model, if you are going to see the BERT model architectures, then this is the one nice one diagram I'm taking. There is some help. So uh, Next sentence predictions means suppose if you are passing the some text data or paragraph and it has 10,000 sentences. So in the BERT model, to learn the BERT model very well, we are splitting those 10,000 sentences into the 5,000. So first 5,000 sentences will be in a right manner, means right sequential manner, and next 5,000 sentences will be in randomly manner. So BERT also try to learn that how those sentences are ordered, how those it should also going to learn the uh, s- uh, means context from those sentences, and it will also try to learn how to arrange all those sentences in the right sequential manner. So that's that's the main part of BERT model architectures. So please remember now there are some differences. I'm simultaneously telling you the differences between BERT models and decoder type GPT models and their differences also. So please remember in encoder decoder part they have so many similarities and so many differences. Still, another one most important differences is that decoder models have one extra part, and it's a mask multi-head attention. Like it has also multi-head attentions like BERT models, but it has also another mask multi-head attention part. So that's why that mask multi-head attention part is provided. So as I have already said that in the decoder model, they will going to see the context from the left to the right before that predicting word context. So remaining part is they have given the mask multi-head attention. And in the encoder decoder model, what happens? The key and in the encoder models, what happens? Key and queries from the encoder are given to the decoder models, and all those values from that decoders are given to the multi-head attentions, and based upon that, it will going to create feed-forward layers, and it will going to predict those probability. I will going to make a separate lectures based upon self-attentions layer, but I will going to tell you that sequence also. So as I have told you clearly that BERT models that architectures. So they may be going to ask you explain me in detail how if you are we have given you any sentence or paragraph, then how it is creating embeddings, position embeddings, how key query value is created, how self-attention, multi-head attentions are created, and how the last output is created. So please tell them clearly that. Suppose we will take the example of bird-based and case models. So now please try to remember those values. So bird-based and case models consist of 110 billion parameters. And please remember that bird-based and case bird means so many bird models have same principle like bird model dimension and sequence length. So dimension is the very most important parameters, and you will going to see that I think they have not. Huh? So here you will going to see in with the analytics. So in the bird-based model, it has 12 transformers encoder block layers, means one encoder block is placed upon the another one. So it has the hidden size of 768, or it's the vector size for each token 768. Please remember that's very important parameters, and they have maximum 512 sequence lengths. Please remember that is a very important size. So you cannot pass all those paragraph or sentences like 1,000 or 10,000 million tokens. You just need to pass all those tokens up to the max 512 sequence length. So that happens. So initially you will take all those words from those paragraph. You will create the max sequence length like 512. Then after that we are creating the tokens. So how you will going to create the tokens? So BERT utilize the word fish tokenizer, and it's very simple. So word fish tokenizer will going to divide the words into the subwords like lemmatizations or stemming, but it's doing the very great work as compared to them. Suppose there is a reading word, then it will going to split reading word into the read and ing. And suppose if there any out of vocabulary word came or any other words, then also because of that subwords tokenization, it will trying to get the meaning for those words. So in this way, wordfish tokenizer will work. And once those subwords are created, after that by using the position embeddings for those words, so they have given this some specific values, because in the LSTM it is the sequential mechanism. So because of sequence, it will going to remember the at which position which word is coming, but transform model will not going to remember that. So that's why we require the position encoding, and that's the very important questions, and every interview will going to ask you. And how you have done all those position encoding. So please tell them that position encoding is done by the sine cosine similarity function, in which it will going to take the various means dimension of the models, then at which positions that cosine, or at which positions, at which dimension that specific word is coming, and based upon that, in that formula, those weights are updated. It means those positions are created. So once you have created all those positions and all those, then it will going to create the sentence embeddings, means from those paragraph it will going to split those paragraph into this sentence, and after sentence it will going to, so this is the reverse flow. Please see, from the top we are going to pass some sentences or paragraphs. So BERT model also have some special tokens, like here you are going to see it's a CLS, or at the last you are going to see it's a SCP. So SCP means separation tokens, CLS means classification. So every beginning of the sentence it has given the CLS as a classification, and whenever sentence is ending, then separation token is added. Also, we are adding the mask. So whenever you are utilizing word with tokenizer, so it will going to give you three output. One is the input IDs based upon those positions, then mask IDs. So the important words have given some mask, and yeah, in this way. And third one is that classification tokens numbers. Suppose if you search this on the net, that's not the important, but still you may be going to face challenges. Word is tokenizer output. So I think in that image here they have nothing. So you are going to see how those words are transferred and changed. So when you implement that Python coding function, that time you will going to get all those in this sequence. I think they are not. Please see that it's very simple. So it will going to give you those IDs and all masking IDs and those, because interview will going to ask you what is the output. Once you will get all those, then we create the token embeddings for each words tokens, then sentence embeddings. Then we are going to create some sentences based upon particular sentence. So E is for one sentence, EB for another sentence. And after that, position embeddings happen, its position is given to those words. And yeah, after that, we generate the three matrices like key, queries, and values. And based upon the embedding dimensions like 768 for per words, and how much you are giving the sequence length. Suppose your sequence length is maximum of bird model is taking like a 512. So your matrix will become a 512 by 768. Then there is dot product happens between key and queries, and we are applying softmax functions. And because of softmax functions, normalization happens, so all values come between 0 to 1. And at the last, we're multiplying this with the values vectors. So we will get the output, and those outputs are connected to the feed forward networks. And to that layer, suppose if you want to utilize BERT model for classification, then you take the classification layer from transformer library. If you want to utilize it's for the name recognition, then you need to utilize token classification layer. If you want to do the question and answering, then you can take that question answer layer, and you just do the fine tuning. But please remember, those are the simple one methods, and try to read those blogs and all those, how those mass language model is created, next sentence prediction is created. And I have just told you about that word with tokenizer, how it's working. But you should know the difference between byte pair encodings, like GPT models are utilizing this, and Roberta model is also utilizing this. You should know the difference between BERT and Roberta model. So Those are the variants of the next version of BERT model. But here you are going to see in the diagram there are so many BERT model variants like Albert, Roberta, Electra, Span bird, Distilbird, Tinybird. So Distilbird is the simplest one, Tinybird is also. But if you want to get those differences, I think they have not given here very well. So in the Roberta model, no, what it will going to do, like BERT model, Roberta model will not going to utilize next sentence prediction. So here they have given the difference very nicely. So Roberta model not utilizing next sentence predictions and utilizing the dynamic masking. And BERT model is utilizing static masking. So what is static masking means once you have given hidden some particular words, those words will not going to change in the next iteration or epoch. But in the Roberta, in next iteration or epoch, those hidden word or static masking will going to change. So that's why Roberta is not utilizing next sentence predictions and all those. Uh, so please remember that points. And it also utilizing byte pair encoding, but utilizing the word face tokenizer. So you should know the difference between what is byte pair encoding, word face tokenizer. So in the word face tokenizer, the words is divided into the subwords, and based upon that you will get the meaning. But in the byte pair encoding, each words is divided into the character level. Suppose if it's your English language, then it will going to create a vocabulary of all those 27 alphabets. And just only on those alphabets, suppose if any particular combination of words is occurring at the highest level, then based upon their frequency, those words have given the max importance. So please remember that points also. So that's the basic architecture of BERT model, differences between BERT Roberta, then transformer architectures, differences between transformer encoder model, decoder models, how those words are created, tokens created, then how position encodings, embeddings created, why it's required, you should know. I have told you already. And at the last, you have need to import some specific classifications layer and you have need to apply those layers on the particular bird based on case models and you will going to get that proper output very well. I hope my video is still visual and yeah, at the last you have need to do the evaluation of models so you can say that precision recall F1 score means those are the best for that classification or other layers. If you are utilizing summarization, please utilize blue score or bilanguage evaluation study score. And at the last, you will create the Flask API. In that Flask API, you will put the model. Then you will create some API request in which you are taking some input text data. Then you are passing those data to the trained BERT models. So there are latest like spacing models where you can train those BERT model and you will predict those entities for specific any task. And at the last, you will create the Docker file. You will apply the Genicorn web server gateway interference to Flask API for to put that model into the productions and you will attach that Docker container image to the Elastic Container Registry for AWS or Azure Container Registry for Azure, and you will create that CI/CD pipeline where if you make any changes in the code, then automatically your code will be deployed into the productions. So in the Azure, you can utilize web service app, and that app will going to create some endpoints, deployment, compotes, clusters, so automatic load handling and balancing will take place. Also, there are so many log matrices and all those through that you can take care of all those. So this is the simple and basic way. So you should know those concepts very well in detail, and you must know. And please remember to read that self attention and what is this and why we require. So self attention is nothing but LSTM has drawbacks that it will not going to remember the long context or if there is any one word have two meanings like apple is a fruit and apple is a mobile, then listing or others will going to fail to distinguish between what is apple. But transformer model like BERT GPT will going to give the each words based upon the surrounding sentence and context a proper meaning. So that's handled in the self attentions and in the self attentions for each vector three matrices are generated like key, queries, and values. So keys are the nothing but the particular position of the word. Queries means the words where we are trying to get the focus, and values nothing but the embeddings or similarities between one words related to the other words. So if we do the dot products of those keys and queries, then we will get the some values of those words, and when we apply those words with the particular means remaining values, you will get the exact importance of those words. So this happens in the attention mechanisms, and when we combine those attentions mechanism means so many times, so it's become the multi-head attention type. So in the bird base containing, it's containing the 12 encoder walks and 12 multi-head attentions, and in this way we are then connecting feed forward layer. So we are connecting all those 8 or 12 multi-head attention into the again single one layer. Then we are applying feed forward layers of max functions. So at the last, it will going to give you probabilities and clear output for those. So this is the basic one. So I have covered all those transformer, self-attentions, BERT models, decoder models, their similarities, differences, and list are still try to cover all your knowledge and all those. And if you have any facing any issue or doubt, please try to ask me in the comment. I hope now my video will be going to upload because already I have created same videos for 45 minutes and it get deleted. Now this time I think it will not going to happen.